Welcome to parabolas, our first conic section that we will focus on. So definition, parabola is the set of all points which are equidistant to a point called the focus and a line called the directrix. So if we were to draw what this means, I'm not even going to draw the axes. So we have a directrix. And then we have a point called the focus. So the most obvious point that is equidistant to each of these would be the point that is halfway between the focus and the line. But then we could also take any point which is the same distance from the focus and the line. So if these two distances match, right, then that point would be on the parabola. So again, any point that is the same distance from the focus as it is from the line is going to be on our parabola. So this is different from how we're used to describing parabolas. Right? We're used to describing parabolas as ax squared plus bx plus c, etc. But they actually meet this requirement. So some other language. The point halfway between the focus and the directrix is called the vertex of the parabola. So the point halfway between the focus and the directrix is the vertex. And then the line that goes through the vertex and the focus is the axis of symmetry. Right. So let's just consider, to start off, a parabola that goes through the point 0, 0. So if we want to find the equation of such a parabola, let's first let's first consider a parabola whose focus falls on the y-axis. Not necessarily at the origin. So let's consider a parabola whose focus falls on the y-axis and whose directrix runs parallel to the focus. Sorry, to the x-axis. So if this is the case, that means the vertex also falls on the x-axis. Sorry, on the y-axis. So to simplify things, let's assume the vertex is at the origin. So to simplify things, let's assume the vertex is at the origin. And the directrix. So the vertex is at the origin, the focus is at the point 0, P, and the directrix is at, therefore, y equals -P. Again, remember the vertex has to fall equidistant or halfway between the focus and the directrix, so we can do this. I need to give myself a little more space. One moment. So essentially the picture we are looking at, then we have parabola that goes through the origin. I'm going to assume it's opening up for now. Although P could also be negative, and that would be fine. We have our focus. This is not going to be at all realistic, but we have, or it's not to scale. We have our focus at the point 0, P. We have our directrix at -P. So note any point on the parabola, any point xy, must satisfy that the distance between 0 and P is the same as the vertical distance, is the distance from 0P to xy is the same as that vertical distance from xy down to the line y equals -P. So for any xy on the parabola, right? The distance between xy and 0P is equal to the distance between xy and we can just take x -P. So this distance between x, y, and x negative p is just y minus negative p or y plus p. The distance between x, y, and 0p is the square root of x squared plus y minus p squared. So what we get then is that y plus p is equal to the square root of x squared plus y minus p squared, or y plus p squared is equal to x squared plus y minus p squared. This is y squared plus 2yp plus p squared is equal to x squared plus y squared minus 2yp plus p squared. Note that that y squared cancels on both sides. Similarly, that p squared cancels on both sides. And we wind up getting that x squared is equal to, or sorry, we wind up getting that 4yp is equal to x squared, or in other words, y is equal to 1 over 4p times x squared. Okay. So this was for any parabola which goes through the or which has vertex at the origin and has directrix y equals negative p and focus 0p. Okay. If we shift that vertex, it just becomes a translation. So if we translate this to a parabola with vertex of hk, focus h comma k plus p, and directrix y equals k minus p, right? So all we're doing is we're shifting that entire thing to having a vertex of hk. Then we wind up getting horizontal shift shows up as substituting x with x minus h. So y equals 1 over 4p times x minus h in parentheses squared. That vertical shift shows up as adding k. So this is any parabola which opens along the sort of vertically, right? Must take the form y equals 1 over 4p times x minus h squared plus k. So this is any parabola. This is a parabola that opens vertically. If we wanted a horizontal parabola instead, the roles of x and y just swap. So a horizontal parabola fits the same equation with x and y swapped. So we would have x equals 1 over 4p times y minus k squared plus h. So our general form of a parabola we have for a parabola which opens vertically with vertex HK, focus H comma K plus P, and directrix Y equals K minus P. We have that Y is equal to 1 over 4P times X minus H squared plus K. Let me shrink this a little so I don't have to go one more page. Okay. Similarly, for a parabola which opens horizontally with vertex HK, focus HK, focus H plus P comma K, and directrix X equals H minus P. We get that X is equal to 1 over 4P times times Y minus K squared plus H. So again, this situation here, we have vertex HK, we have focus above that and directrix below that. The distance away is P. This is the equation we get. Versus for the horizontal case, we have a vertical directrix. We have a vertex at HK. Our focus is shifted to the right or left then. And again, the distance between our vertex and our directrix is P. So these are our equations that we get for our parabolas. This is essentially one of the vertex form of the parabola with that slightly odd 1 over 4P out front. So for an example, let's consider the parabola. X equals 2y squared minus 12y plus 7. Our job is to find the focus and directrix and graph the parabola. So if we have x equals 2y squared minus 12y plus 7. To get this into standard form, we need to complete the square. So we have to complete the square to get standard form. To do that, the first thing that we're going to do is we're going to factor out that 2 from the y squared and minus 12y term. So we have x is equal to 2 times in parentheses, y squared minus 6y, and the parentheses plus 7. Y squared minus 6y, we take that minus 6, we do minus 6, we divide it by 2, and then we square it to figure out what we need to add on the end. So this is positive 9. So we will have x is equal to 2 times y squared minus 6y plus 9. We still have our plus 7. Then we just added on. So we just added plus 2 times plus 9, or positive 18. And so that means that we have to subtract 18 to balance out. So we have then that x is equal to 2 times y squared minus 6y plus 9 is just y minus 3 squared. Then we have a plus 7 minus 18 becomes a minus 11. So we have a vertex of 3, negative 11. We know that this 2 out front is 1 over 4p. Or in other words, 8p equals 1. And so we have p is 1 over 8. So this means that we have focus of, since we're in x equals, that gets added and subtracted from the h, right, from our x coordinate. So our focus, we would have 3 plus 1/8. We keep our negative 11. Our directrix is going to be a x equals 3 minus 1/8. So in terms of graphing this parabola, we go to the point 3, negative 11. I'm going to, in fact, blow this way up, at least along the x-axis slightly. We're going to go to the right by 1/8 to get to our focus. We go to the left by 1/8 to get to our directrix. And then our points are all the points that are equidistant between the focus and the directrix. So you're not going to be precise by any means, but something like this. And so this is how we can sort of graph a parabola using the focus and directrix as opposed to the vertex and plotting points. The vertex and plotting points is obviously faster, but it can be useful to know that focus and directrix as well. That is parabolas. In our next video, we will take a look at ellipses.